learning and how you improve in the model in the challenge. And to just to start a good start with this, I want to firstly in our pipeline of the models. So the CNN or the convolutional neural network, actually what it does, it's to try to find the best, let's say, best feature detectors what we call it a feature map. So if you work with the image processing, you will firstly in computer vision in general, you want to handcraft some feature doing pre-processing like detection edges or find histogram or some important features in images. Then you feed it in any type of machine learning classifier that will be used later for you. So the convolutional neural network actually it's trying to find the best feature extractor for you. So this is just for the start. Now when we want to do a transfer learning, why we use it and how we use it efficiently. So you have in the transfer learning we have some problem, and this is a problem in image in vision we talk. We don't have sufficient data or we don't have sufficient hardware to do it. So to gain a good and high accuracy on that, we use some pre-trained models and use it in the field. Now there is a tips and there is a things that you must check when you work in any transfer learning problem, or maybe in deep learning problems by general, or machine learning in general. You have to have firstly to know what is the highest accuracy you could achieve by anything. We call it as under ONG call it the bias. You have to have a bias. This bias is some indicator to you what is the highest level that you could achieve when you train the model, so you know where you're going. So the bias by the first we set it as the human level of classifying this thing. So you have a problem. We here have 102 classes from flowers. So you as a human, what is the highest accuracy you could classify this flowers? 80%, 90%, 99%. So just set the bias that that is the highest level a human can achieve, or maybe you going doing your research and seeing the state of the art and the research papers that working on this specific problem, or maybe much harder problem. What's the highest accuracy achieved? Now you're setting your bias. When you're setting your bias, now you have something that we call it when you train your model and your model reaching to the bias, the bias will help you to identify if your model achieved overfitting or not. Why and how? You have the model, you're having your training set, and you have some test or validation sets. Now you see your accuracy. Let's say our bias in this problem is 99%. Let's say the human could classify it in 99% of accuracy. Okay, this is our bias. Now, in terms of training, we have a training set. The training set, the training set that we have in here. Let's say you achieving 93% of accuracy. Okay, and in the validation set you achieved 94%. Now you are not you don't think about your model is underfitting. Because in the test set, if you achieve higher result than the training set, it is okay for now. you will try what to do, build a wider or bigger network to, firstly, in the training set, you must overcome the test set to at least reach something near to your bias. When you reach something near your bias, now you know you are not overfitted, and it must be literally different than the test. If it is 99% for the bias and you achieve 98% in your training, and you achieve in the test set 97, this is okay. But if you achieve 93 in the test set and in the training 98, it is huge difference between your training and the test, and it is little different between your training and the bias roof, on the bias threshold. So what you have to do is that you have to think how to reduce the difference between the test and the training. Okay, so you have something we call it a trade-off between bias and variance. This is a problem that you could achieve by when your test is near your training set. You will have some general, what we call it, your model gaining general over the data. The model is okay. The model can be good. Your model is not very overfitted. So the overfitting that your training set accuracy is overcome the test accuracy. But if you are underfitted, that your test is overcoming your training accuracy, and maybe both reaching good accuracy, both will reach good accuracy, but they very overcome the bias term. How we could say that? Let's say that the highest accuracy human can achieve in this problem is 90%, and in your training and test, in your test, you achieve 99%, and in your training you achieve 99%. So okay, both are equal, but it's not okay because the human achieved 90% and in your model you achieve 99. This is that in this case you are overfitted. Why? Maybe your test set is very similar to the training set, and it's not randomly taken, and there is not so different from them. Even the model is not trained on it, but if they are the same, and if they have some that variety on them, you can't achieve the separation that you could take in your mind, that the test is a good judgment to me. So I'm talking about this bias and variance because you will achieve this problem when you're building your transfer learning model in the pytorch challenge. Let's back to the pytorch challenge. So now in pytorch challenge you have to select a pre-trained model, and you have to build or try to mimic the classifier in the pre-trained model that you choose. Now, the pre-trained model, and why we go to transfer learning in this problem, we already have little amount of data. Don't look on your data as a big data. It's not a large data set. It's how I judge about this. It's not large data set. In any class, you have something near 100, 200, and in the semi class there is intra-class variance. So there is very similarity between classes. The problem is very hard problem, and if you searching in the research, you're not achieving the 99% that you see it in the leaderboard. In the research papers, there is hard work done and there is many things done, and they're not achieving this because we testing right now in our challenge and in our unofficial leaderboard on the validation set that is being given to us, and they are nearly similar to the training set that we take from the challenge, but there is a different test set they will use to judge your score. So now let's back to our choosing the pre-trained model. I believe that you first have to try the most general model that you could achieve a good accuracy on it on the training set and test set. from the pre-trained. Achieving a good accuracy, what I mean by achieving good accuracy and general accuracy, I mean that you getting your test is above the training, your test accuracy above the training. And why this? Because let's say that we get VGG 16 and we train it for 5 or 6 epochs. Okay, we achieve in the training set 93% or 83%, let's say this, and in the test set we achieve 84 or 85%. Okay, now we not train it so many because we have another phase. The another phase that we will use is that we will unfreeze some layers and not the whole model. Just understand this concept. You don't have to unfreeze the whole pre-trained model. It's a big model and maybe your GPU or the code lab will not be sufficient to train the model. You have to unfreeze some layers. Now choosing the layers that you have to unfreeze is the tips here. And how to choose the layers that you want to unfreeze. There is some guide that you could take. Firstly, in the CNN was the layers that you build in the CNN, that the first layers is the one that have some general information, some general feature structure about the task you have. Deeply you go inside your model, the most specific part of the task in your hand is being extracted. So if we're talking about a model that trained to classify peoples than other things, the first, let's say we have 10 layers. The first 1, 2, or third layers, just extracting the shape, the edges, extracting the body from the background, something like this. Now the deeper you go, maybe in the 9th or the 7th layer, you will go the human eye shape, the face, the body architecture. This will go in the deeper model. So this concept and this foundation will be used when you firstly choose which pre-trained model, and secondly which layer that you have to unfreeze. How this be? What possibility that your task is similar? What possibility that your task have with the pre-trained model task? Firstly, we taking a pre-trained model based on ImageNet. Okay, most of any pre-trained model that's been available for download to you that has been trained on the ImageNet. Okay, and this ImageNet is trained about a very large number of classes and almost anything that you could see in the world. Okay, these pre-trained models have trained on common objects and common things. This is okay, and the task in your hand. The task in your hand, either firstly you have a small number of data, and this small number of data are similar to those inside ImageNet. Okay, this is probability number 1. In this case, you have a small number of data and they are similar to, and have some similarity, let's say, in the classes in the ImageNet. What you have to do, you will have to, the pre-trained model, freeze it and not train it at all and build classifier. You will use the CNN, the pre-trained model, VGG 19 or ResNet or anything. You will use it as a feature extractor, a static feature extractor, and you will build either neural networks or support vector machine, I don't know, XGBoost or any type of classifier. You will find it getting the highest accuracy that possibly you could take. This is your choice. If what? The task in hand have a small number of data and the classes are similar to those or have some similarity to those in what? In those in ImageNet. This possibility or probability number 1. Maybe the task in hand have large amount of data, and there is similarity in what, some similarity in the classifier you take, or the problem of in the ImageNet, because we're taking pre-trained model in the ImageNet. Now, because we have larger amount of data, we have some level of flexibility. What we will do, we will take the pre-trained model, we will freeze, let's say, the half. We will take, let's say we have 8 layers, okay, and we will unfreeze only the last the 7, and then the 10 and the 9 and the 8 model layers, or just unfreeze the last layer, unfreeze the last 2 layers. Depend on you seeing the classifier and how deeply this classifier can go. Maybe some classifiers in some model have 200 and more layers, and when you go deeper, they're getting very little specific features on the given image. So you have to have some judgment, some mental judgment about it. Now, you're choosing the right layer to unfreeze, but not unfreeze the first layers. Don't try it and not unfreeze the whole model. Just unfreeze small number of layers from the last, or from the end of your classifier, of your pre-trained model. And now you unfreezing this, and what you do, you let's say we're building a flat neural network as a classifier, and we go to train. Now in this, there's two approaches, and this is actually what's happening in our PyTorch. This probability is what's happening in ours. There is two kind of approaches could happen. Firstly, I will do this approach from the start. The neural network that I build as a classifier will start initially random weight, but the last layers have a good weight, good initial weight. Now we're training the last layers with the classifier in the hand that we built, we architecture it. The gradient will be calculated between this last layers, we unfreeze it, and the neural network that we built. This random initial weight maybe affect your accuracy. So there is approach, we do the following. We're taking the old way by freezing the whole CNN, the whole pre-trained model, okay? Do a training for only the neural network that we built as a classifier. Why? Let's train for if we achieve the max result in 10 epochs, do it for 5 epochs. Don't go to max. Just what we want to do right now here, just to overcome the initial random weight and getting a good weight. This good weight will be based on the static classifier give us a good feature, but not for this task. It's a good feature at all. It's good features. We will overcome the initial random weight. Our neural network that we build will have a good weight. Now our neural network have a good weight to start with. We will start another phase of the training. By this phase, what we will do, we will unfreeze. Firstly, we was freezing the whole pre-trained model. Now we will unfreeze just the last layers, let's say the two last layers, and also we unfreezing our neural network, the classifier. We will train the classifier and this unfreezed 2 or 3 last layers. What's happening right now, that these 2 or 3 last layers have a good initial weight because they are already trained on the ImageNet, and our neural network has a good weight also because we train it on a good features. Now your model will achieve very good accuracy if you was taking 90% on your training with the first phase. In the second phase we will achieve 95 or 96%. But keep your eyes on what? On your bias and variance, on the overfitting and the underfitting, on the on the judging that your accuracy, is it reasonable, is it okay that the model can achieve this? Because believe me, I have been taking many hackathons and I have many validation sets. When you judgment your model on the validation set that been given to you from the competition, you will surprise that there is a huge number of difference between the score you got in this validation set and the test that they will score you on. This happened in Kaggle, this happened in Analytic Valdilla, and happened in many of private hackathons that I've been entered. So don't judge by that you get in 99% on the validation set that's in your hand and the test set that they will use. Because they will try by the end to do the generality of your model. And maybe your test set is very, let's say, small. What will happen if your test set is very small? If you have 10 images for one class and you misclassify one, it is 90%. But when you have hundreds of images for this class, this percentage will different, and also the variation between images will become different. And for the same class there is many variation in many shapes, and by the end if you got it, you will know that this type of task, and you have to judge which model. Now we will talk about the other probability, but which model you will select from the pre-trained model that exist on the model zone on the PyTorch. The model you will choose, focus on the models that have some let's say about it, some layers that give you some generality, that have batch normalization, that you could put some dropout on them. Try to not build a neural network that is deeper after the model, because this deeper network will very memorize your data and will give you good accuracy, maybe and maybe not, but in the test that they will work, they will not working good. And the wider the network you choose, after the CNN, you have to put high dropout. If you choose to use 1,000 or 2,000 or 4,000 neurons in your layer, in your neural network layer, put some high dropouts, maybe 0.5 or something like this, because this high dropout will help you to achieve generality. And by the end, you have to achieve generality. You don't have to focus on achieving high accuracy on this little validation set. And also, by the way, there is a test set that is available on the GitHub that is what been used on the research papers. You have to test your model. Some models that achieving 99% have been achieved 61-69% on this test model. So to know where you are getting, and maybe they will use it in the tests or the score, I don't know actually. Now getting back to the probability, to get back to the transfer learning, the probability now, we have testing two probability. You have a small data set, and this small data set have similarity to the image nets, the pre-trained model that pre-trained on the image net. The second probability that we work on the PyTorch is that you have large data set and have some similarity. There is another probability that you have a small data set and they are very unsimilar, and you have a large data set and they are very unsimilar. If you have already a large data set and they are very unsimilar, don't use the transfer learning. Build your architecture, because maybe you will achieve a good accuracy with very small architecture, and the small architecture will be very sufficient for helpful for you and for your work, because maybe you could use it on a mobile model or something like this, because you will have by the end a small a number of parameters. when you have a small number of parameters, that your model will work faster, that will predict faster, and this will could achieve model by the end. But if you want to try the transfer learning, you just start with the initial way that has been in this architecture, and believe me, this architecture a very good, very big architecture, and this big architecture and large amount of parameters will you need multiple GPUs to work on. There is approach then that's been used on the competition. Also, I will give you some tips. What they will use, they make the first phase, as we said, a static convolutional network, and start the neural network that's connected to it, the classifier, with train it with some little amount of epochs, and getting good result, not the max result. If you use VG19 or VG16, you will achieve, let's say, 91%. Don't achieve this the max result, achieve something less. Now, when you achieve, because why I'm saying not achieve the max result that could be achieved by the fixed classifier and the neural network that connected to it. Why? Because if you achieved this, the max, then your neural network will be very specific to the feature that's being getting by this fixed feature extractor. When you try to retrain this feature extractor or tune it, your neural network will not getting very high differences, because they have been getting them passed by learning in this on the old feature extractor. Now, we have agreed that we will not achieve the max. Let's say the max 91. We will achieve 89 or 90. Okay. Now, I'm talking about the test set, not the train set, by the way. Now, the second phase that you will start, they will unfreeze the half or maybe the whole, okay, about the pre-trained model, also the classifier. But they're using a very little learning rate, and I'm saying very. When you hear me say very, this is 0.0, something like this. You will have to try. So I have to try some ranges. This very little learning rate will not affect the fixed classifier, but it will train it, and also will not affect the weights that inside it. So this very little training rate will protect you from being learning faster and entering either the plateau state or getting the overfitting, a problem that you don't want to be in. Now, there is two things also you could use in your train. Is learning rate scheduler and reducing learning rate on a plateau. To me, I'm using reducing learning rate on a plateau. Why? Because if I choosing the learning rate, and my model is a train, and it's achieving good accuracy in the test set, I don't want it to reduce the learning rate. I want to achieve a good accuracy and continue progressing. So once the model, let's say in this phase, my model achieved 80%, and in the next epoch it achieved 75. Let's say this is dropout. This drop in the not dropout. This drop in the accuracy is meaning I'm not focusing on accuracy, but I just make it. I want to make something sense to it. When you're reducing the learning rate, you focus on the loss, because it is very accurate way that to judge your model. But I'm just want to make some things common to you and clear. Now, when I see the model doing like this, and I give it a patient by one, so there is something that monitor the learning rate, monitor the validation loss. When you see this drop in between the previous and this current epoch, we will reduce the learning rate. We happily reduce the learning rate because we now achieve a bad state. You know, when you're doing gradient descent, things are not very good curve. There is some little we call it the local minimum, something like this. We have some places that it's considered a good place on training, a good place to achieve good accuracy, but by the end they are not the optimal solution. So what we will try, we will doing it of course have different explanation and different solution based on the optimizer use. There is stochastic gradient descent, there is Adam gradient descent, there is RMS prompt, and there is many types that you have to choose. But what I'm saying, let's get back to scheduler and the reduce on a plateau. Reduce on a plateau will monitor this learning, and now when you see this is not achieving good, it will reduce the learning rate. This reducing the learning rate will affect the momentum or the movement of our learning steps, and this will maybe helpfully help us getting out of the plateau state, okay, or getting out of the bad current situation that we are on the scheduler. On the scheduled learning rate, what they do for some amount of, let's say, reduce the learning rate by each 4 epochs, each 3 epochs. What they're trying to do, that they want, when the farther you train, the less learning rate you have. When you have less training rate, you will have less movement step, or small movement step. The small movement step, this will help you not being in the overfitting state when you're training a lot. Both solution or both method, the scheduler or the reducing on the plateau state, have them situation, and you have to choose between them carefully. And also you have to choose your optimizer, the good there is not good or bad optimizer, and by the way, everything is about you testing and try and error. But there is some optimizer that work good with specific problems and tasks and specific architecturing, and there is some other that they not giving good work and good result. And also the learning rate, there is not a good range between this and this. There is always a range that you choose and you consider it efficient for your work. Now this is all about the transfer learning and what to choose, what method that you have to choose when you doing your transfer learning, and the tips for you that please try on this challenge some model that have some batch normalization and some separate layers. Now to choose the layers in PyTorch, those who coming from background of Keras, and Keras we just have number of layers that we turn off the layer. It's all the layer will turn off and not be trained. And in PyTorch thing is different. You don't have to the iteration is about the parameters, and the parameters maybe you have 100 parameter in one layer that are trainable. So don't judge by this how you could choose the layer. By the end, the model in PyTorch are something like dictionary, so you have either choosing them by name, or you have to model.feature. This layer 1, this layer 2, or something like this. If you want, I will share with you code of how to choosing layers from the pre-trained model, so you control this layer, turn it off, turn the gradient on it off or on, manipulating them, taking some layer from it and replace it, some of method that is using, and by the way, try to choose a model that have average pooling, that will give generalization over the data, and it's reducing some in some task they overfitting, it reduce it and achieve a good general model. I'm just saying this because I can't tell you how to build your model. I just want to give you thoughts and idea and think that is being used in researches and labs and also in hackathons or something like this, and sharing with you some knowledge that I get in from the years that I work in this field. And thank you for watching me, and Hope to see you later, and anything you want to ask about, just leave your question or reach me on Slack at Ma'moon and or on Facebook or something like this. And have a good day and bye bye.